Okay, quick recap of chapter 2.1. So that's learning how to do different styles of division. This is going to be a two-part video. Wait for part two. I'm trying to show you how you can take polynomials and do long division with me, just as you did when you were in grade school. So as a recap, if you were to divide, so this being the dividend, right? And this number will be the divisor. This symbol states that this large number, 4,583, is going to be divided by the number 12. That's a big, tall order, I guess, if you want to do it in your head. So instead, what you do for long division is you count the number of digits that you see in your divisor, and you count off how much of that is from the dividend from the left side, until you divide. Excuse the loud noise. So 45 divided by 12. How many times can I, or you know what, let's keep it as multiplication. This is what I would like to do. What do I multiply with 12 to get as close to 45 as possible without going over? And the answer is actually 3. So I'm going to put a 3 there at the last digit of 45. So 3 times 12 gives me 36. Maybe I could do it as a highlighter. This is important. 3 times 12 is going to give you 36. And I am going to subtract. Okay? So 45 minus 36 is a 9. Is 12 larger than 9? Yeah. In other words, is 9 smaller than 12? Yes, which means I did the right thing. Next digit now comes down. You're going to continue dividing in this way. What can I multiply with 12 to get as close to 98 as possible without going over? And it looks like it's an 8. So that's a 96. So 8 times 12 gives me 96. And now with that, I am going to subtract. And the answer is 2. Is 2 smaller than 12? Yeah, that means you did it correctly. The last number drops down and turns this into a 2-digit number. What do I have to multiply with 12 to get as close to 23 as possible without going over? The answer is 1. So 1 times 12 gives me 12. And when I subtract, it's an 11. This is smaller than 12. I have no more numbers to bring down. And so this is going to be my remainder. And the answer that you get at the top, this is your answer, aka an answer to a division is called a quotient. Okay, so these are 4 words that I'm going to be using and throwing around. Another thing you have to be aware of, this is some new vocabulary. I'm going to introduce what we call a division and a quotient statement. So let me move these words up top. Okay, it's going to look like this. A division statement is when you write what you had before, the dividend, and you show me what that is a product of. So if this were to be sort of broken up or factored or divided up, I could say that 4583 is 12 multiplied by 381 with an extra 11 left on the side. If I were to write it as a quotient statement, literally a statement of the answer to division, okay, I am going to divide all 3 of these terms. So divided by 12, divided by 12, and divided by 12. And that is what a quotient statement is. So how we start it is 4583 divided by 12 is equal to 381 plus 11 over 12. That's your quotient statement. In general, division is sort of like the original function is equal to your divisor, right, multiplied by whatever your quotient is plus whatever your remainder is. For a quotient statement, the original function divided by whatever the divisor is equal to the quotient plus whatever the remainder is divided by that divisor. So in this case, it's 12. Keep that in mind. You can pause it, write something down. I'm going to come back to this and ask you for a division and quotient statement in the future. So let's try to do the exact same thing for polynomials. Because after all, 12 is a number, so you can use it as a divisor. But isn't x plus 1 also considered a number? We just don't know what the value is. So if we can long divide with 12, you should be able to long divide with x plus 1, although it might be a little bit more complex. Here's an example. X to the power 4 plus 4x3 minus x squared minus 16x minus 14 is going to be divided by g of x, which is x plus 1. Take a look. I wrote everything in chronological order, descending degree, 4, 3, 2, 1, and 0, with x plus 1 as my divisor. So the same thing applies. I have two digits, or two terms rather. So I'm going to look at the first two terms. What do I have to multiply with x plus 1 to get that as close to this as possible? That might seem complicated. So instead, I'm going to ask you to focus on just the first term. What do I have to multiply with x to get x to the power of 4? The answer? X to the power of 3. Okay. So x to the power of 3 multiplied by this entire binomial should give you x to the power of 4 plus x to the power of 3. And subtract. X to the power of 4 minus x to the power of 4 is a 0. I'm not going to write it. 4x cubed minus 1x cubed is 3x cubed. And you're done. What's next? Just like regular long division, you bring the next term down. And then you repeat. I'm going to use blue this time. What do I multiply with x plus 1 to give me, rather, what do I multiply with x to give me 3x cubed? What do I multiply with x to give me 3x cubed? You should have gotten positive 3x squared. So let me multiply this up. So this is 3x cubed plus 3x squared. And we're going to subtract. And before we get a chance to subtract, I just want to point out, notice how my answers of x to the power of 3, x to the power of 2 are lined up with the same degree in the dividend. They just look nicer, so I highly recommend you do that too. 3x cubed minus 3x cubed is 0. X squared, negative x squared minus positive 3x is negative 4x squared. And then drop it down. Minus 16x. I'll use red. What do I have to multiply with x to get negative 4x squared? The answer is negative 4x. And so I'm going to do this. And that will give me negative 4x squared minus 4x. And the answer is, I'm running out of space. So you can try to figure that out on your sheet. I am going to navigate myself away. And it's going to make this a little messy, but bear with me. There. So 0 and x, negative 16 minus negative 4. That's negative 12x. And lastly, negative 14. What do I have to multiply with x to get negative 12x? It's negative 12. So you have negative 12x minus 12. Subtract it. You have negative 2 as your remainder. Okay. That's it. I'm going to bring this down. Division statement and quotient statement. I'm going to see if I can squeeze it in. The division statement is the original function is going to be you know what? Let me erase this. What is the original question again? Oh, it's going to be tough to remember. So for division statement, I would write x to the power of 4 plus 4x cubed minus x squared minus 16x minus 14 is equal to x plus 1 bracket x cubed plus 3x squared minus 4x minus 12 bracket minus 2. Right. It is. By quotient statement, I can rewrite this, same thing. This original function, so that's a dividend, divided by the divisor is the same as there, and that's the remainder. See any restrictions? Well, you did divide by x plus 1, and you know that you can't divide by an x, so by a 0, I mean, so that cannot be a 0, which means x cannot be a -1. That's all. So that's essentially it for a long division. The remaining questions on the back are going to be extra practice for you, and you can look at the textbook as well. Please be familiar with long division, and to the point where you're sort of annoyed by it because it's so long. Because the next part of this video, or this lesson, I'm going to show you a shortcut cut synthetic division. You probably will like it a lot more. Most students do. But don't forget long division. All right. Let's take a look at final bit. Okay. This question, again, if you want to skip it, you can, but this does talk about one more thing. Please note that if a function is written not in descending degree, you have to rearrange it. So notice how 3x to the power of 4 is written here, then it's x to the power of 3, and then x to the power of 1, and then -19. You also might notice that x to the power of 2 is not a term that's in the dividend. What do we do with that? Well, to make long division easier, we actually put a 0 as a placeholder. Because as we start multiplying out, you will see that you need some space for x squared terms. Just add it there if it's not in the original equation. All right, here we go. This one's going to be a little bit long, but anyways, we have something multiplied with -x squared to get as close to this as possible, and that would be 3x squared. That becomes -3x4 plus 3x cubed plus 9x squared. Subtract that, becomes 0, -2x cubed minus 9x squared. And you drop down the next one. Okay. What do you think the next one should be? So let's continue. What would it be? I need to multiply this with a positive 2x. That becomes -2x cubed, positive 2x squared plus 6x. If I subtract everything, that becomes a 0. This becomes a -11x squared, and that becomes a -4x minus 19. That's a plus 11, -11x squared plus 11x plus 33. Subtract, -15x minus a 52. Yeah, so even a remainder could be a polynomial. So by division, let's see if I can squeeze this in on the bottom somewhere.
No. I like that. Someone there. Someone in our business.
Plus x cubed is equal to, it would be, this is a divisor, this is the quotient, and this is the remainder. I know it's a long one. And then for the quotient statement, what you do is this would be divided by this. This would be left alone.
No, I think she's one.
This would be there. Okay, and that's it. I think at the bottom of the page, you start talking about the remainder theorem, and that's actually important. It actually makes all this a lot easier. So if you remember, so I'm not even going to go into this. I'll explain in just a second. In the original, remember how if you wanted to find the remainder, which was -2, you'd have to do all of this junk. Well, what we noticed was, as a pattern, if we noticed that by remainder theorem, if x plus 1 is what you're dividing by, the root of x plus 1 will give you the remainder. Long story short, is this. Say that f of x is equal to x to the power 4 plus 4x3 minus x squared minus 16x minus 14. If you factor this, you get some bracket, x to the power of 3, blah, 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 and minus 2, right? If you plugged in -1 in here, in other words, if you plugged in -1 in here, what does that bracket turn into? That bracket turns into a 0. And you take a 0 and you multiply it with anything, what does that turn into? It turns into a 0. And what's left? The remainder. In other words, f of -1 should give you -2. -2 happens to be the remainder. Therefore, if you plug in the root of a factor, in other words, the factor is x plus 1. If that is a 0, that means x equals -1. If you plug in a -1 into the function, the answer is same as the remainder. That's remainder theorem. If you plug in a root of an equation, you should get the remainder. So let's test it. F of -1 is equal to -1 to the power of 4 plus 4 times -1 to the power of 3 minus -1 squared minus 16 -1 minus 14. This is 1, -4, -1, positive 16 minus 14, -4 plus 16 minus 14, that's -2, just like our original question. That's remainder theorem. Okay, I'm going to let you go and practice some of these questions below. If you have any questions, please come and see me, confirm your answers and whatnot. And yeah, try it. I hope to hear from you so that you can clarify any confusion you have. Good luck.